The second question is read this way. The first measurement of sea depth was made in 1840 in the central South Atlantic, where a plummet was lowered 2,425 fathoms. What is this depth in meters? So you're given conversion factors here. And let's begin. What is given? What is desired? What do we need? Well, if you read it, and reading is very critical in this class and in all of science, reading and writing, says you are given 2,425 fathoms. That was the measurement. So we begin with that, 2,425. And it's asking you clearly, what is this depth in meters? So you're given 3 conversion factors. Now, I'm going to just give you a word of precaution here, is that you may be given 3 conversion factors. And most of the time, generally, that's how many you need. If you're given, let's say, 3, 4, 5, that's what you need to use. But sometimes if you read, depending on the question, you may need to come up with some conversion factors, like it shouldn't be really given to you because we know this intuitively that there are 60 seconds in a minute. So again, some conversion factors you have to remember, but generally they should be given to you, except of course we talked about in the last problem where you have to know the metric prefixes. So let's begin. What should we start with if we have fathoms here? It's this one we have to start with. So we start by saying, okay, 1 fathom in the denominator and 6 feet in the numerator. And this makes sense because that makes the fathoms go away. Now what's next? So we cross it out, remember, go to the next. We have feet here, so then we should use the second one. 1 foot and 12 inches. Once again, you should understand why we put the foot in the denominator in the second conversion factor, because you need them to cancel out. If you put the inches in the denominator, then they wouldn't be able to cancel out. And then finally, we have this last conversion factor. We have inches, so we must have inches bottom here. That's 1, and that's equal to 0.0254 meters. Very well. So all we have to do now is calculate it, but I need to tell you something about significant figures. The easiest rule for remembering how many significant figures to end with is just to ask yourself, how many do I have in the given number? And however many you have in the given number, that's how many you should end with in your final answer. So if I have 4 here sig figs, then I should have 4 significant figures at the end. I do not care about all of these because if you read before, these are exact numbers and you do not apply sig figs to them. Exact numbers are not measured numbers. So we care about our measured numbers, and that's what limits the certainty. So let's begin. So from my answer, I get the full answer. So we can write it down. I get 4,434. Let me erase this meters here so we can include the whole number. 0.84 meters. Okay, so I need 4 sig figs. So I'm going to count my first 4 sig figs. 1, 2, 3, 4. I need to end with that 4. There's an 8 after it, so I need to increase this to a 5. So my final answer will be 4,435 meters. Now let's go on to the next problem. It says here, the prescriber ordered, and these are dosage problems important for the healthcare, but they tend to be introductory ones. Of course, there are more complicated ones for those who are going to major in the healthcare industry. So it says here the prescriber ordered amoxicillin, which is an antibiotic that has a 20 milligram per 1 kilogram of body weight. So the dosage here is 20 milligrams per 1 kilogram of body weight. Drugs are standardized this way. So calculate the dose of this antibiotic for a child who weighs 85 pounds. Okay. So if you notice here that the measurement is 85 pounds, this is not measured. You can look up any medicine you have at home. It's going to say the dosage. Like if you have Tylenol at home, it might say 500 milligrams. That's the let's say in each tablet, right? Or how many should be given for a child. So this is what's given. So it seems you have 85 pounds. And you need to calculate the dose, okay? So just think about it. What is the dose in? What am I going to give the child? Am I going to give him the dose in kilograms or in pounds? No, it's in milligrams because, again, drugs come in that unit in milligrams. And so we have, or if it was in milliliters, if it was a suspension or a liquid. So we have to end with milligrams. Okay. So let's begin. I have 2 conversion factors here. You might thought, oh, I only have 1. So here's the first one. And here's your second one. So a word about, so we already talked about this one, but a word about this. If it says 20 milligrams per kilogram or 1 kilogram, you are free to simply invert this any way you want. So you could say 1 kilogram per 20 milligrams. It depends on, again, what are you calculating for? But that's the dosage here, is for every kilogram of body weight, body mass, you have to give that person 20 milligrams. So if they weigh this much, let's calculate that. So notice here that pounds is not something we use in the metric system. So we need to convert to kilograms. And you have a conversion factor right here. So if I have pounds and I have pounds down here, that's 1. And then on the top, it's going to be 0.454 kilograms. So they cancel out. Now I need 1 more. If I have, and remember what I said, I cross it out. So obviously if I use this one first, then I need to use what's left, which is this one right here. Now I have kilograms, so that which should go down here. And that's 20 milligrams on the top. And remember, I started with 2 significant figures. That's how many I need to end with. So if I were to do the calculation for this, it would be 85 times 0.454 times 20. And that gives me an answer of 771.8 milligrams. Now I need two significant figures, so I'm going to, again, follow the same rules. This is my first significant figure. This is the second one, so I need to round. What comes after the 7? A 1, less than 5. So it would be 770. Now, you might have thought that this should have been maybe 77, but I want you to be careful with that because that's a very common mistake. 77 versus 770, these are totally different values. This is 10 times as much. So what do I do when I need to round and then just keep the number of sig figs? Well, you use trailing zeros. Remember, this 0 is not significant. So again, be aware of that because you need to maintain the value. You cannot simply go 10 times less, right, to 770, or 77. So again, always put trailing zeros when you are at that point. So in this case, my answer is 770 milligrams.